Alright, how do we solve linear regression inferences? So the basic relationship between y and x can be denoted through y hat equals a plus bx. B is your slope, and its relationship with r can be explained by this equation. B equals r times the standard deviation of y over the standard deviation of x. The previous equation was a statistical equation used to estimate our new equation, where mu of y demonstrates that the true mean response has a straight line relationship with x. A and B represent parameters alpha and beta. A alpha is our y-intercept, and B beta represents the true slope. Before performing a linear regression test, you have to verify the 4 conditions. Our first one is independence. Each observation should have no effect, nor should it relate to any of the other ones. You can find this by just reading the question carefully. Once you've verified independence, you can move on to condition number 2. The relationship is linear between x and y. To view this condition, you can just look at your scatter plot. The third condition when performing a linear regression inference procedure is that the standard deviation of the response about the true line is the same everywhere. To do this, add a residual plot. Once you've done so, you need to see if the residual plot follows a normal distribution pattern. Access now the normal probability plot.
This is your residual plot.
Once you've produced a residual plot, we can head into our 4th condition. Create a new document and graph your residuals into a normal probability plot. Now check for a linear pattern. Since we have already established our conditions for linear regression t-tests and intervals, we can finally learn how to write our hypotheses. Our null hypothesis for a linear regression t-test is always that there is no true linear relationship. This can be written also as beta equals 0 or rho equals 0. Rho is representing your true correlation. The alternative hypothesis is that there is a true linear relationship. This can be written as beta does not equal 0 or rho does not equal 0. After establishing both of your hypotheses and verifying all of your conditions, you can proceed to writing the test statistic. The test statistic for a linear regression t-test is t equals b over the standard error of b. Don't forget to include your degrees of freedom, n minus 2. Lastly, SAB is the standard error of our LSRL slope and can be found through a calculator. After plugging in some sample data into our calculator and running a linear regression t-test, the output is as shown. We can find our test statistic right here, the p-value under that, and the degrees of freedom under that. After analyzing the data produced by our calculator, we can conclude a rejection of our null hypothesis because our p-value is so small.
We'll be back right after this.
Hello, my name is Jamal. Every 60 seconds in Africa, a minute passes. Together we can stop this. Please spread the word. Thank you for your attention.
This road is musical.
Is it?
It's musical.
Really?
It plays a tune as you drive.
As James has a music degree,
Is that a tune?
Top Gear, the new series, coming soon.
How it feels to chew 5 gum. New 5 gum. Stimulate your senses.
Hey man, you trying to find love in your life?
Yeah, of course.
Have you tried all those other sites?
Yeah, I've tried, but they're not for me.
Alright, have you heard of statisticiansmeet.com?
No, I haven't.
Now, at statisticiansmeet.com, we can find you the love of your life with 95% confidence. Using our top paid statistician, he will, with 95% confidence, make sure you have a higher probability of going on a second date. Don't believe us?
I'm just a man with some tiny hands, looking for a girl with some normal curves.
I just met my husband on statisticiansmeet.com.
Now I'm confident I can find a date.
Alright. Statisticiansmeet.com.
Each variable within the formula for a confidence interval represents different things. B is the slope of the LSRL. T star is your critical value and can be found on a table or it can be generated by a calculator. In this case, assuming we're at the 95% confidence level and our degrees of freedom is still 8, our T star value would be 2.306. The resulting confidence interval is 1.03591 plus or minus 2.306 times 0.0911, where B is your first number, T star is the second, and your standard error of the slope is the last one. This interval simplified down can just be shown here, and our final conclusion would be that we are 95% confident that the true slope of the line is between 0.8258 and 1.2459.
3, 2, 1.
Once you verify, okay, start over, I'm sorry. I don't know what happened.
2.
The previous equation was a statistical set of